The complex z satisfies this equation where t is a real number is given that one of the root is this form. So kk plus I. I'd like to write this as k1 plus I easier later. Okay. So if this is a root, right, meaning this will satisfy this is what? The first thing I would like to look at it is this is quadratic. Okay. This is quadratic. And this is not conjugate roots theorem. Okay, so quadratic means we have two roots. We are already given one root. So to find the other root shouldn't be any issue. Stop k1 plus I into the quadratic equation. The reason why I bring the k out is so that I don't want to deal with so many k's. Okay, I just want 1 plus I. I can foresee that by factorizing the k out, right, it makes life easier. So I'm gonna just put k1 plus I into the 2 plus I minus I k1 plus I plus t equals 0. Okay, so slowly expand it. Here you go. T is real, right? T is a real number, okay, Ken? So you just group the imaginary and the real. So the imaginary, this is the real, sorry. This is the real together. Then the imaginary is this guy. Imaginary. Compare the real and imaginary parts. So reject this one obviously, as k is not non-zero. So hence when k is 2, you can solve for a t. Minus 2 square plus 8 2 plus t equals 0. T is minus 8. I put minus 8. T equals to minus 8. There you go. So the other one is this guy. So then I want to solve the other root of the equation. So I like to look at this quadratic equation. So now I solve for my k already, right? Meaning to say, I know that the other one would be imaginary. It's not conjugate roots theorem because this one is what? Complex coefficient. Once you have a complex coefficient, you cannot use conjugate root theorem. You cannot just say k minus ki is also a root. No, it's not. So you can't do that. So how do you then solve it? You just do what you do in secondary school. Okay? If alpha and beta are roots, right? You in secondary school, you will write like that, right? Correct? This is what you write, okay? Correct or not? Am I making sense? These are two roots, right? So you do the same thing, but you have to put the a in front. Okay, so but you can do that, or you can also use quadratic formula if you want to. Okay, so there are many ways to get the answer. So maybe we'll see what is what. I'm going to use this one first by comparing the coefficient. Okay, so this one will be ax minus alpha, or z minus alpha, then z minus k plus ki. This is the root. This will then be in turns equals to z square 2 plus I minus 8i z plus t. This expression here. But it's not hard to see that this a here will be this 2 plus I because the coefficient of z square is 2 plus I. So by comparing, you can see that. But then you just sub all the values in. The easiest is you want to expand, but don't have to expand everything. Don't have to expand everything. The easiest is to compare the constant. You agree? If you expand this guy, this one multiplied by this one multiplied by this one will be minus 8. By comparing the constant, you expand this guy, you'll be able to see. So what I'm saying is this guy multiplied by this guy here is equal to this guy. Make alpha the subject, then I can bring over. So this is method 1. You just compare the coefficient, two roots. You let other root be alpha, then z minus alpha. Must put the a here because the coefficient is is 2 plus I. So that will be your a. Then you just, this alpha will be this guy. So the other root is this guy. So how do you do method 2? Method 2, remember what I said initially. I always eyeball this is quadratic. And we know how to solve quadratic equation, right? Z. So method 2 is you just pray and hope that this will work. Okay, you just use this thing and you see if it works or not, bro. I don't know whether it works or not, but we try, okay? We try. Of course, after you do everything, method 1, method 2, depending, right? You just understand that you can use GC and check your answer. Always check your answer. So this case, you just put this as a B. This one looks manageable. So this is your C lah. So yeah. Minus B plus minus B square minus 4A C. Easy game. Then divided by 2A. Okay, how do you find square root of 2i? Okay, method 2, if they allow you to use GC, just understand that square root of 2i is this guy. Okay, 1 plus I. Okay. But even if you, okay, so if method 2, this question allows you to use GC, this one you evaluate, this is 1 plus I lah. Okay, understand this one. Okay, or you could, okay lah, I think technically you can use the first root to deduce that this is 1 plus I. But if not, how do you find square root of 2i? If they don't allow you to use GC, right? Remember square root of 2i, initially we talked about this, square root of 2i is equals to a plus bi. Then what you do is you just square both sides. Okay, then you just compare lah. So 2ab is equals to 2, then a square minus b square is equals to 0. Then you just solve lah. You solve this inequality here, you get a equals to 1, b equals to 1. Okay, so anyway, this one here, you get 8i plus minus 4, 1 plus I. Then this is 4 plus 2i. Okay, then key in calculator. You do that already. So repeat, this guy can use GC and evaluate. If they don't allow, we just do this usual stuff. You just let square root 2i be a plus bi. Then you just solve a and b is equals to 1. Then this guy, you multiply, you get this value here. So this should be your answer already lah. Then you just multiply by conjugate roots. Okay, 2 minus I, 2 minus I. This is the first one. There you go. So there are two methods. Both give you the same answer.